Welcome to part 8 of our 9-part series on assessment. This is going to be split into 2 sections since the latter half is much more mathematical than the first. So if calculus isn't your thing, just watch the first part of the video where we deal purely with this on a conceptual level, and then it'll be in the second video, linked on the same playlist, where we actually get into the math. So we're going to go through what is computerized adaptive testing, why we do it, and how it works in the first video on part 8, and then implementation will be in the second video. So first of all, what is computerized adaptive testing? Well, it's about using the student performance to guide the test. It'll zero in on a student's ability score. The computer will possibly secretly mark each question as the student responds. So instead of trying to focus on grades or percentages, this is about figuring out where is the student at? What is their ability level in the context of this course? So why do it? You can get a quick and accurate measure of student ability. The percentage scores associated with it are almost meaningless. Every student who writes it will have about the same target percentage, which is usually in the 50 to 75% range, depending on the design of the test. What matters is what difficulty level of questions are the students being given in order to attain that target percentage. In order for computerized adaptive testing to work, you have to try very, very hard to make sure the student can get neither 0% nor 100% on this test. And we can get a clear picture of student ability in a fraction of the time. I used to work for a private tutoring company that used third-party assessments like the California Achievement Test or the Canadian Achievement Test on paper. Sometimes looking at 85 questions administered over a little over an hour. And when we switched to computerized adaptive testing, we got more accurate results in 34 questions in 15 to 20 minutes. So how does this work? How is it that much more effective? After each response, the question is graded immediately. The students may or may not see the result. That depends on the assessment itself. The computer then determines the student's most likely ability level based on the pattern of correct and incorrect responses received. Of course, if they're only correct or only incorrect, it'll adjust the difficulty level until that changes. And then the next assessment item that's presented to the student is at or near the estimated ability level. Now, this is huge for supporting students who are not close to their current grade level, whether they're very high or very low. So if you have a grade 6 student who is reading at a grade 3 level, giving them a paper test based on grade 6 content isn't going to tell you much because they're going to struggle to get anything right whatsoever, and most of what they get right is going to be as a result of guesswork. With a computerized adaptive test, it is much less frustrating for the student because it meets them at their level, and it's more accurate for the instructor, because then you get a clear picture of where they're at in the context of that grade 3 level they're performing at. Which skills are in place, which ones are not. So they will continue until they've completed a set number of questions, or until they've gotten down to a specific uncertainty level, depending on the design of the test. I've seen tests that work both ways. So if a student starts off getting the first question right, and that question is based on their current enrolled grade at school, well then it'll keep giving them harder questions till they get some right and some wrong. And then estimate where their ability level is. If they get the first one wrong, it keeps giving them easier questions until they finally get one right. And then again, calculates the student's most likely ability level based on that pattern of responses. And it will take it from there. Now we are going to get into the nitty-gritty on this in the next part of this video. So the second video for this part, we'll get into the specifics of implementation, including all the calculus involved. So if you're just trying to understand the concept behind it, you are free to wrap up with part 8. And if you want to dig into the details, well, come back for the next part.